Good evening, everyone. My name is Navid Nikayen. I'm professor at Eurocom and also a board member and MOSAIC5G project group coordinator at Alliance. Today, I'm going to present you MOSAIC5G project, whose mission is to provide an agile and open 4G, 5G service delivery platforms and use cases. MOSAIC5G has a dual objective. First is to provide an ecosystem of open source 4G, 5G service platforms, a set of reusable components and use cases. Second is to provide a software development kit, an SDK, allowing to architect and compose a custom 4G, 5G network service delivery platforms, which is tailored to a particular use case. Both allowing to unlock open innovation in mobile networks and enabling emerging use cases found in 5G and beyond. Mosaic 5G consists of three platforms. First, FlexRig, which sits on the top of radio access network and consists of a controller and agent. It complies with the recently specified E2 protocol and supports a range of deployment from monolithic to disaggregated. The counterpart on the core network is called Flexcn. It not only acts as a controller, but it could take the role of different entities in the core network, for instance, application function. On the top, we see Triaromatix, which is an orchestrator and management system sitting on the top of Kubernetes and operating both on the radio access network and the core network. Triaromatix also provides a repository of images and the blueprint which could be reused for certain to deployment scenarios of interest or could be used as a template to create a new use case or deployment scenario. All of the three component and platforms of the Mosaic 5G are all released under OAI Public License 1.1, the same as what we have today for 4G, 5G RAN, 5G C, and SB Gateway C and SB Gateway U. So let's start by going a little bit into the details of the FlexRig, an SD-RAN platform. Starting from the bottom, we see the user plane function, which could be 4G or 5G. On the top, we see the agent library that extending the functionality of the user plane with the E2 compliant protocol. So the agent library could interact with any ORAN compliant rig through the E2 protocol, or it could also interact with a FlexRig controller through a E2 compatible protocol. It has to be noted that FlexRig could also act as a ORAN compliant rig. FlexRig is composed of three layers: server library, which implements the E2 termination plus some helper and utility functions; the iApps, the internal apps, which implement the service models; and then on the top, the communication or the Northbound API, which could be of different form, ranging from the message bus to the REST and so forth. And on the top, we see the X app and DBs that could interact with this platform through this communication interface. So in short, FlexRig provides a generic E2 agent, and today we have reached to have this generic E2 agent to be implemented, and also this basic FlexRig platform, both of them compliant with the E2. The FlexRig controller is designed to be customizable and composable for multi-RAT scenarios, for multi-service scenarios, and multi-vendor scenarios. We are envisioning to implement advanced service models, both at the agent and the controller, such as slicing, traffic control, and mobility management, similar to what existed before to some extent on the FlexRAN platform. We also adopted an ultra-lean design which features simplicity, efficiency, and reusability. And this basically allows FlexRig controller to be specialized for a particular use case. Now let's move to the Flexcn. Flexcn is a software-defined core network platform. Flexcn could have different roles which are all scenario dependent. At the very basic, Flexcn could be a 4GC and 5GC controller. But at the same time, Flexcn could take the role of network exposure function, application function, or even network data analytic functions. Flexcn features the following functionalities: monitoring of different network elements such as AMF, SMF, and UPF, as we see in the picture on the right, which is currently implemented and supported. It could feature, this is what we plan to implement, traffic control policy, which interacts with the AMF, SMF, PCF, and the UPF, UE subscription, which interacts with the UDM and the UDR network function, mobility management through interaction with the AMF, and a slicing through the interaction with NSSF. We also apply the similar design features as FlexRig and ultra-lean design in order to make sure that the FlexCN is efficient, simple, and reusable. The last platform, Triaromatix, is designed to provide an agile 4G 5G operator. It consists of three main components: multi-X in blue, which the layer that supports different container technology ranging from uh, Docker to Podman and to others. It supports also multi-version and multi-vendor scenario. MonX is a entity that is in charge of monitoring of the whole deployment, not only the infrastructure part, but also the network resources, which are exposed through FlexRig and FlexCN. And finally, AutoX, which is in charge of automation and autopilot, which is the actual operator, which is, let's say, enhanced and has the interface to a AI and ML engine, monitoring the entire network deployment and constantly optimizing and improving the network deployment. Triaromatix also provides a number of use case blueprints, both for the 4G and 5G. It also used as a use case driven CI/CD framework. In terms of the MOSAIC5G roadmap, we have a very dense and very feature rich roadmap that we are a little bit ahead of time with respect to the original planning, which is really good. It allows us to do a better testing, better debugging of the software to produce a quality software. So uh, today we already generated the generic E2 agent. We validated with Hello World service model as well as KPM service model. We also perform the compatibility of this E2 agent with ORAN RIG Cherry version. So in essence, the OAI new radio and OAI 4G, they are extended with this E2 agent, and we could manage to perform the compatibility of OAI with the ORAN RIG. We also have the basic version of the FlexRig and FlexCN, which only as of today uh, able to perform the monitoring of the RAN 4G and 5G. We plan to extend this to certain control and provide a feature-rich SDK for the X apps, provide new service models such as slicing, such as traffic control, and uh, orchestrate and manage all of those through Triaromatix. The final word is that Mosaic 5G project group is just bootstrapping. It strives to unlock open innovation in 4G and 5G arena from a rich ecosystem of reusable platforms, components, and use cases. We would like to ask all of our community to join us in this innovative journey. And for more information on this, I put the link on the project charter that you can actually consult and see what are the plans and what is the exact roadmap that we are uh, planning to put in place. So thank you for your attention, and I hope you enjoyed this presentation, and looking forward to collaborate with you very soon. So if there is any question, I'm now available to answer your questions. Thank you very much.